ಶುರು ಮಾಡಿ.
Good morning friends, I am Dr.M.H.Annaiah, Professor of Mechanical Engineering and Vice Principal at Saptagiri College of Engineering, Bangalore. Friends, in today's session, I am going to speak on the projection of prisms. Before I take up the actual problems, let me just brief you about the difference between a prism and a pyramid. Friends, for example, if you have a pyramid, a triangular pyramid, it will have a triangular base and on its lateral surface there will be a number of triangles. Here is a triangular prism pyramid, it will have 3 triangular bases. Similarly, a square pyramid will have a square base and 4 number of isosceles triangles on the lateral surface. Now, since I am going to start with the prism, let us have a comparison between a prism and a pyramid. So a prism has got throughout the height the same cross section. So wherever you cut it parallel to the base, you get number of slices. For example, in a triangular prism, if you keep on slicing these parallel to the bottom face of the solid, you get number of laminae. Whereas in case of the pyramids, you will also be getting number of laminae, but each reducing in size when we move from the base to the vertex of the solid. So a prism by definition is a solid which has got a bottom face and a top face, and on the lateral surfaces you can see number of rectangular faces. For example, if I take the example of a triangular prism, by definition a triangular prism will have a triangular bottom face and a triangular top face, and these two faces are connected by a number of vertical rectangular faces. Hence, a triangular prism will have 3 rectangles on its lateral surface. A top is a triangle, bottom is also a triangle. Likewise, if we have a square prism will have a square base like A, B, C, D, a square base and a square top, and again it is connected by number of triangles. That is, the bottom face and the top face of the solid are connected by number of vertical edges or longer edges. So a triangular prism will have 3 rectangular faces on its lateral surface, namely A, B, B1, A1. Likewise, you have second one, third one. Similarly, in a rectangular or a square prism, you will have 4 rectangles on the lateral surface, a square bottom and a square top. And similar to the pyramids, the center of the top face and that of the bottom face are connected by an imaginary line called the axis of the solid. So, in today's problem, in this today's session, let me start with the projection of a triangular prism. So, I have a problem here. It runs like this. A triangular prism having shorter edge measuring 25 mm and axis 60 mm long rests on HP on one of its rectangular faces. So first of all, is a triangular prism? Yes, this triangular prism you have got here. It has got 3 rectangular faces, a triangular top and a triangular bottom connected by these rectangles, and the height of this solid, the total height of the solid or the axis length is given to be 60 mm. The shorter edge here means these edges, that is AB, BC, CA. They are the 3 edges for the top face. Likewise, you will have A1, B1, B1, C1, C1, D1. 3 faces, 3 sides for the bottom face, resting on HP on one of its rectangular faces. See, in the previous problems on pyramids, we used to have the solid resting on the triangular faces, like a triangular pyramid ABC resting on triangular face. Here, instead of this triangular face, for all the prisms, we have got rectangular faces on the lateral surface. Hence, it is possible to make the solid to rest on one of the rectangular faces or on one of these slanted, the longer edges. Okay. Now, The size of the prism are given. The size, the shorter edge are these three shorter edges, three at the top, three at the bottom. These three are the longer edges, and the length of each is equal to 60 mm. On one of its rectangular faces, friends, the initial placement of the object is exactly similar to that of the pyramids. In a triangular pyramid or in a rectangle, whatever it may be, if the pyramid has to rest on one of the triangular faces, we used to keep one of the base edge to the right side of the observer and we used to rotate it like this. Similarly, in case of the prism, you have whatever is prism, it has to be made to rest on one of the rectangular surfaces as required in the problem. So initially I have to place the object on HP such that the object is resting on one of the triangular face of the solid and we get the front view and top view. Then afterwards we are going to rotate through an angle of 90 degree so that the object will rest on one of the rectangular faces. What is the procedure followed? See, now let me have the initial position of the object written before we go to the second step. Friends, we are having this XY line and I mark VP and HP. The problem is on a triangular prism. It has to rest on one of the shorter edges. Now I am going to place the object on the P such that one of the shorter edges A1, B1 will come to the right side of all the observers there and get the top view and front view. So top view is going to be a triangle, an equilateral triangle. Front view is going to be another reduced rectangle. Let me write down the initial position of the object. The object has to rest on one of the rectangular faces on HP. So I just mark this triangle having side of B is equal to 25 mm. Each shorter edge measures 25 mm. So I just mark this as ABC, A, B, C. This ABC is the top view of the solid. What happens in case of these prisms? The top and bottom faces are exactly identical and hence you will be able to see only these three corners. The bottom three corners are covered by the top three corners and hence you will be able to see only ABC. So this ABC represents the top face of the solid. For the bottom you have got one more, that is A1, B1, C1. So here when you look from the top, you are able to see A, B, C. A1 which comes below this A, B1 which comes below this B. Similarly, C1 which comes below C are not visible and hence we are going to show them only in the first problem. A1 inside a bracket, B1 inside a bracket and again C1 inside a bracket. As usual, locate the center of the solid by bisecting any two adjacent sides. And this is how we are going to get O, O1, the center of the top and the bottom face O. So let us get the front view of the solid. So from the axis center, I am going to write a vertical line indicating the axis. The height of the axis is given to be 60 millimeters. So I just mark 60 millimeter here to indicate the height of the object or the height of the solid. So this is 60 mm. The top center is O dash and the bottom is O1 dash. So obtain these points ABC for the bottom. So here you get B1 dash C1 dash for the bottom. For the top, let me complete that. So this is O1 dash over. The front view will complete that type of the problem. So this you have got here. So this is the getting point here. So I just mark top face A, B, C. So this will become A dash, this will become B dash, this will become C dash, and this is your O dash. So for marking the bottom face, below A dash, put A1 dash. below B dash, B1 dash, below C dash, C1 dash. So this is the front view of the solid when it is resting on HP on one of the triangular faces. Friends, you can observe in the front view, we have got two vertical lines. One is B dash C dash, B1 dash C1 dash. Other one is A dash, A1 dash. Here, if you see this, the right side line, this represents a rectangular face because you have got 4 points on it. Which are these 4 points? The points are B dash, C dash, B1 dash, C1 dash. So, you will be having this line represents a rectangular face. A rectangular face. You should know the reason why it is rectangular, because there are 4 points. The line contains 4 points, and hence this represents a rectangular face or a rectangular surface. So what about the axis? As per the general rule, whenever any of the solids rest on the base on HP, the axis will always be perpendicular to HP. The axis O dash O1 dash is now perpendicular to HP. Okay, so now it is like this rectangular faces HP on one of its rectangular faces. Now friends, you can see in the initial position, the object is resting on its triangular bottom face. The axis perpendicular to the HP. He says it has to rest on one of the rectangular faces. So here this last line represents the rectangular face. So to make the object to rest on the rectangular face, geometrically I should just redraw this figure such that the line B dash C dash B1, this last line rests on this. So I am going to redraw. We will call this figure as number 1. I am going to redraw this figure with the same dimension, same height, all this. We will call it as figure number 2, and let me mark this. This was like this, it is placed like this. So this will be your A dash, this is B dash, this is C dash. For the bottom, this is A1 dash, this is B1 dash, this is C1 dash. Axis from B1, BC, you just take that. So this is O dash and this is O1 dash. Friends, you can see in the initial position we had the object resting on its triangular face. Now I have redrawn this figure with one of the rectangular face B dash C dash B1 dash C1 dash resting on HP. So this is the rectangular face. I'll write down here rectangular face on HP. I will show you practically how it looks. Friends, this is a rectangular face you have got. We had placed the object like this. In the front view, you could see this rectangle. Now I have redone that face with the rectangular face on HP. So in the front view, very obviously you get a rectangle. This white rectangle you get. So with the regular procedure and get it. So let's see now. I will start with the top face. I will get all the 3 points. So vertical line from A, if you draw from here, horizontal line from here, this point is going to be point A. Likewise, B and C are here. So horizontal line from B, vertical line from B, the point of intersection will give you B. Similarly, vertical line from C, the horizontal line from C, the point of intersection of these two will give you C. So A, B, C. O, the center of the top is O is here, O is here. This is A, comma, O. And likewise, for the bottom face also, you are going to get on the similar lines. If you get the points one by one, this is going to be C1, this is going to be A1, this is going to be B1. Friends, you have got all this, and this is A1 and also O1, because the center of the bottom face of the solid. It's not the base, it's the bottom face. So as per the rule, join all the borders of the solid by straight lines. Yes, I have joined the last line. This is the last line here, last line here. Now we have to confirm whether this A1 is a full line or a dotted line. Friends, see here, we have this rectangle like this, we are made to rest like this, and this is the topmost line is the line CC, and that is when you look from the top, you will be able to see AA1 or A-A1 dash. So this has to be a full line. This longer edge AA1 also covers the axis OO1, and prominence or importance is to be given to the edge of the solid. Hence, I am not going to show the axis here. Friends, you can observe now, whatever figure we had in the first is redrawn with a rectangular face on HP, and this is the top view you have got. So in the top view, you can see here that the axis of the solid, axis is OO1, and you can say very well, this axis is parallel to VP, as well also this axis parallel to HP also. But what is he saying in the question? He says, draw the projections of the solid when the axis is inclined at 30 degrees to VP. Friends, now the axis is parallel to VP, and I am going to redraw this figure number 3. This figure such that the axis OO1 is inclined at an angle of 30 degrees to VP. So I will just mark a line here. At an angle of 30 degrees to VP, is 30 degrees. On that, I am going to draw this figure. So you can draw here either A, B, C, the top face nearer to the observer or bottom face nearer to the observer. It is one and the same. It will not make any difference at all. So I am going to redraw this figure number 3 as figure number 4 on a line inclined at 30 degrees like this. So I am going to have this OO on that. Very simple. Easy to reproduce. So this is the figure we have got. So now what I will do, I have got this figure number 3. I am placing like this. So this becomes CAB, CAB, and this will be C1, A1, B1. This is C1, this is A1, this is B1. And friends, you can see this point also coincides with your O1, and this is O, A, O. Now friends, you have placed the object such that the top face of the solid is nearer to the observer and the bottom face is away from the observer, or it is nearer to the VP, the vertical plane. So let me get the face A, B, C, which is nearer to the observer. Follow the procedure and get all the 3 corners of the top face. Let me start with point A. Vertical line from A, horizontal line from A. The point where those two intersect is A dash. Is it clear? Then likewise get point B and C. Vertical line from B, horizontal line from B, they meet here. This point is B dash. Likewise C dash. Vertical line from C, and then vertical line from here, C, the horizontal line from C, they intersect here. I call this point as C dash. A dash, B dash, C dash is completely visible. So I show this by full line. ABC is the top face of the solid, and the center of the top face is O. Horizontal from here, vertical from this point is O dash. Friends, you have got the front view of one of the top face of the solid. On the same lines, I should get the points for the bottom face. Remember friends, in all the prisms and also in the cylinders, whatever the figure you obtain here for the top face, you are going to obtain a similar identical figure for the bottom face. By following the same procedure, I am getting these points. Very simple. So this is A, ABC. 3 points you can get. Now this is your A1 dash. A dash, A1 dash is one longer edge Like C you have got here, this is C1 dash, this is B1 dash. Friends, now I told you the figure you get here is exactly identical to this. That is A dash, B dash, C dash is exactly identical to A1 dash, B1 dash and C1 dash. So here, as per the rule, the borders of the solid are visible. So I join by a full line, I join this by a full line, and this bottom line is a full line. And now friends, you can see the edge, this AC, is not visible to the observer, and hence I show this by an invisible line. Mark O1 dash, the center of the bottom face, O1 dash, and here you can see friends, we have the final solution with the axis marked dash dot dash dot dash dot. Friends, this is the final front view of the solid. We mark it as a free, and this is the top view of the solid TV. And now, how to confirm whether the solution you have got is correct or not? It is very simple. First of all, it's a triangular prism. As we have a triangular prism with top face a triangle and front view rectangle, which we marked as figure number 1. And then he says it has to rest on a rectangular face in figure number 1. The last time B dash, C dash, B1 dash, C1 dash has got 4 points. It represents a rectangular surface or rectangular face which is at 90 degrees to HP. That is redrawn with B dash, C dash, B1 dash, C1 dash resting on HP, and you obtain the top view. And in the top view, all the 3 edges were visible, longer edges and also last faces were visible. So we have got the top view, and in the top view, the axis O1 is parallel to VP. But in the question it is specified the axis has to be at an angle of 30 degrees to VP. So I have redrawn this figure 3 as figure number 4 with the axis O1 inclined at an angle of 30 degrees to VP and obtain the front view. And in the front view, friends, it is very clear if the object has to rest on one of the rectangular faces, there should be 4 points touching the XY line. Hence, we have got here B dash, C dash, B1 dash, C1 dash. This line represents a rectangular surface which is on HP. Hence, this gives you the complete solution for the problem. And friends, I thank you very much for viewing this. And this is Dr.M.H.Annaiah signing off.